on page 88, topic 16, and we're going to do 5 problems from this page. Problems number 4, 8, and 10. So we're going to do 4, 8, and 10, and then we're going to do 13 and 16. So all of these are word problems where we have to translate them into equations. These equations are generally, these are equations that involve fractions. So we're going to have to find LCD and then multiply through. So let's start with number 4. 1/4 of a number is 5 less than 1/3 of a number. Find the number. So if here's 1/4 of the number x over 4. X is the number and x over 4 is 1/4 of the number. If it's 5 less than 1/3 of a number, which would be x over 3, we have to add 5 to it, okay, to get the equation. Now, the LCD of 4 and 3 is 12. Now, we have to realize that if we take the larger number, because this denominator is smaller, this would make x over 3 larger than x over 4. The difference between these is 5, and that's an alternate way of saying this. 1/4 of a number is 5 less than 1/3 of a number. So we take the greater number, which is 1/3, we take the smaller number, which is 1/4, quarter, and the difference between them is 5. So you can either choose this equation here or that one. I'm choosing to work with this one. I'm going to multiply through by the LCD, which is 12. 4 times 3 gives me 12. I'm going to multiply each term by 12 on these 3 terms. So 12x over 4, the 4 goes into the 12 3 times, and I get 3x. 12 times 5 is 60, and 12x over 3 is 4x. So if we transpose the 3x over to this side, we get 4x minus 3x equals x, x equals 60. So 1/4 of 60 is this, 1/4 of 60 is 15. If x is 60, then 1/3 of that is 20. And if we add 15 here plus 5 here, we get the 20. So that's the check on the solution. The next problem, number 8 on page 88. What number must be subtracted from each term of 9/17 to yield 1/3? So here's the 9/17, and the number that we're going to subtract is x. So x is our unknown. So it says what number must be subtracted from each term. In other words, the numerator and the denominator, we're subtracting that from this. So the LCD is 3 and 17 minus x. So we can multiply both sides by 3 times 17 minus x. We could also cross multiply, and I'll explain that. Maybe a lot easier just to multiply 3 times 9 minus x equals 1 times 17 minus x. That's probably the easiest. But let's just make it a little more difficult, and we'll see what I'm getting at. Here we take 3 times 17 minus x, and we multiply the left side by the 3 times 17 minus x. So the 17 minus x cancels here, and we are left with 3 times 9 minus x. We multiply the right side, 1/3, by the LCD. The 3's cancel, and we get 17 minus x. Now this result here, which comes from here, is exactly the cross multiplication answer. 3 times 9 minus x equals 1 times 17 minus x. So as I said, cross multiplication might be the easiest way to do this, but we've shown that if we use the LCD, we get the same result. 3 times 9 is 27. 3 times minus x is minus 3x equals 17 minus x. So now we bring the minus x over here. Minus 3x plus x gives us minus 2x. And 27, bring it over to this side, gives minus 10. 17 minus 27 is minus 10. So minus 2x equals minus 10. 2x equals 10. X equals 5. So now, of course, we go back to check our answer. And we put 5 here and 5 here. So 9 minus 5 is 4. 17 minus 5 is 12. 4 over 12 is 1/3. And we look at the right side of the equation. It is also 1/3. So the solution x equals 5 looks like a valid answer. Next problem. Find the sum of a number and double its reciprocal is 19/3. So we let x equal the number. The reciprocal, this is x over 1, so the reciprocal is 1/x. We just make the denominator into the numerator and the numerator into the denominator for the reciprocal. So the equation that we have is a number plus twice its reciprocal right here equals 19/3. And this simplifies to x plus 2 over x equals 19/3. So you can see that the LCD is 3x. We multiply each term through by 3x. So 3x times x, 3x times 2 over x, and 3x times 19/3. 3x times x gives me 3x squared. The x cancels here. This x and that x cancel. They're typed a little differently, but we just cancel. This is an x, and this is an x, so we have 6. And here the 3's cancel, so we get 19x. So now we have 3x squared minus 19x plus 6 equals 0. And when we have this middle term being negative and the last term being positive, it has to be minus minus here. We factor this as 3x minus 1 and x minus 6. You can see that the inner term is minus x, minus 1 times x, and the outer is minus 18x, so minus x and minus 18x gives me the minus 19x. So the solutions are 3x minus 1 equals 0, in which case x equals 1/3, and here x minus 6 equals 0, in which case x equals 1/3. So if we assume we start with 1/3, then twice its reciprocal, which is 3, we turn this upside down, it becomes 3, and we multiply it by 2, we get 6. So we get 1/3 plus 6, and that equals 6 1/3, or 19/3. If the number is 6, then twice its reciprocal, twice the reciprocal of 1/6 is 2/6, which is 1/3. Now we add 6, and excuse me, let me go back over there. Let me go back a little bit. If the number is 6, and twice its reciprocal, twice the reciprocal of 1/6 is 2/6. 2/6 is 1/3. We add 6 and 1/3, we get 6 and 1/3. So it doesn't matter. The solutions for these are 1/3, and so they give identical solutions. They both work. So, go. Okay, how much money did a man had if he had $10 left after spending a half of his money at one store and a third at another? So let's assume that X is the amount of money that he started with. He started with X. And here's what he started with. He spent half of it at one store and a third of it at another store, and then he was left with $10. So x minus a half. This is a half of his money is a half x. A third is x over 3. So we have x minus x over 2 minus x over 3 is 10. We multiply the 2 times the 3, so we get 6 as the LCD. We multiply each term by 6. 6 times x gives us 6x. 6x over 2 gives us the minus 3x. And 6x over 3 here gives us the 2x. 6x minus 3x minus 2x gives us x. 6 minus 3 minus 2 gives us 6x minus 5x gives us x and the 60. So let's see if this works. We take the 60, we spend half of it at one store, which is 30, a third of it at another store, which is 20. What are we left with? $10. That's the right side equals 10, so the left side equals the right side. Okay, last problem on page 88. A man spent a quarter of his life in school after 4 years of early childhood. Also, he spent 3/7 of his life working and enjoyed 23 years of retirement before he died. How old was he when he died? So what we know was, if we assume that x equals his age, and we take away the early childhood, and we take away the years in school, and we take the years away working, we're left with his years in retirement. So we take his age, and he spent 4 years in childhood. His age is x, but here we got the minus 4 because he spent 4 years. Then he spent years in school, which is a quarter of his life, x over 4. Quarter of his life. So that's x over 4. Then he spent 3/7 of his life, in other words 3x over 7 in his life, and then he was left with his retirement. So the key thing is to look at this equation. Age minus the early childhood years minus the years in school minus the years working equals his years of retirement. Because we know that is 23. Okay, so now we multiply. Here we have a 4 and a 7, so we could multiply through by 28. So 28 times x gives me 28x. 28 times 4 minus 4 gives me minus 12. 28x over 4 gives me the minus 7x. And this would be, we're multiplying through by 28. 28 times 3 would be 84. 84x over 7 gives me minus 12x. Multiply this by 28, I get this term. Multiply this by 28, I get that term. Multiply this by 28, I get that term. Multiply this by 28, and I get the minus 12x. And 23 times 28 gives me 644. So now I have to bring all the variables to the left. 28x minus 7x minus 12x, that's these, the variables on the left, and I transpose the minus 112 to the right. When I take 28 minus 19 here, I get 9x. 644 plus 112 gives me 756. So x equals 84. So let's think about this now. 84, a quarter of 84 he spent in, or 21 years in school. 3/7 of 84 would be 7 into 84 goes 12. 3 times 12 is 36. So that's the years he spent working. And his years retired is 23 and 4. So if we add up the years in school, the years in working, the years retired, and the years in early childhood, right here, it sums to 84. So we know we've got the right answer. So this completes our discussion of page 88.